All right, this is the second part now, and what they've done is we're talking about the same function, but now they've given us some values of the derivative at some of those places that we had the points of inflection before. It says if g of x is equal to this, here we have a quotient rule, and f of 7 is 18, what does g prime 7? So what they want to see is quotient rule. Definitely have that on your note sheet if you're not 100% sure. It's bottom times derivative of the top minus top times derivative of the bottom. So if we do the derivative of that, it's going to be 1/2 times x plus 2 to the negative 1/2. And a negative 1/2, the negative means you would bring it to the bottom, and the half means you do square root. So I'm actually going to write it like that. You can leave it as x plus 2 to the negative 1/2, but I think this might make it a little easier to solve out. Divided by the bottom squared, and if you square that square root, you're just going to get x plus 2. So any version of this here, as long as it is that, will get you a point for sure. Then we want g prime 7. So if we want to put 7 in there, 7 plus 2 is 9, square root of 9 is 3, times f prime 7, according to the table, f prime of 7 is 8, minus f of 7, which we were told was 18, times 1 over 2 times the square root of this, which was 3, all over 7 plus 2, which is 9. Now, they're saying you don't need to simplify things. As long as you know that's correct, you can move on. So something like this, you could stop and get a point. You do not have to keep going. If you did keep going, you have to make sure it's correct. So this is going to be 18 times 1, 6, which is 3. 24 minus 3 would give you 21 over 9. If you wanted to reduce that to 7/3 or 2 1/3, any of those are fine. But again, all of these give you the same credit. You don't get extra for simplifying. So as soon as you know you're right, you can kind of just pull the plug on it. Even with this one, if you wrote that as 1/2 x plus 2 to the negative 1/2, and you put 7 in, and you had this as 18 times 1/2 times 9 to the negative 1/2, you can leave it. That's okay. You'll get full credit for it. And that's something to kind of prepare yourself for on that day. What does this integral equal, and show the work? So when we integrate, we're going to go ahead and do this part first. The integral of the f double prime would get us back to f single prime. The 3 is just going to hang out there. And the integral of 4 is 4x. And we're going to do fundamental theorem on this. So we're going to go top minus bottom. So if I put the top in, I get 3 times f prime 1. F prime of 1 is negative 3, plus 4 times 1, which is 4. That's the top, minus 3 times f prime 7. According to this, f prime 7 is 8, plus 4 times 7, which is 28. All right. So again, this is correct. If you had done this, I think they give you a point for the integration here. So showing that integral would get you a point. And then this would give you a point for the evaluation. You don't have to keep going. If you do keep going, it's negative 9 plus 4, which is negative 5, minus 24 plus 28, which is 52. We would get a negative 57 as the simplified answer. But again, all of this is worth the same amount. So don't feel, once you have it in there and you know that's the answer, you don't have to calculate. All right. I gives us a version of a chain rule here. So we want to find the derivative of m. So the derivative is going to be the derivative of the outer. Derivative sign is cosine. Leave the inside alone. Times the derivative of the inside, which is f prime of x. So that would give you a point for showing that derivative. Now we're going to put 1 in for x. So the derivative of 1 will be cosine of f of 1, which was pi, times f prime 1, which according to the table was negative 3. Again, now this is correct. This would get you the point. If you go further, the cosine of pi is negative 1, and negative 1 times negative 3 is 3. Now maybe they do something on this problem to force you kind of to go that route. Maybe they have you, I don't know, do a tangent, who knows, right? But on its own, point for the derivative, a point for plugging it in correctly. Okay. Then J here gives us f of 3 equal 20 and says, what is this limit? So anytime we have a limit, we should plug our value in right away, right? So this is going to be this is going to equal 4 times f of 3, so it's going to be 4 times 20 minus 80 over e to the 0 minus 1. That's going to give us 0 over 0. Okay? And as soon as we see 0 over 0, that means we're dealing with a L'Hopital's rule. And so what we want to do on L'Hopital is take the derivative of the top. The derivative of the top would be 4 times f prime of x. 80 would go away. And the derivative of the bottom would be the e repeated times the derivative of the exponent, which is 3. I'm going to put that 3 in the front, and the negative 1 is going to go away. So this is our derivative of the top, derivative of the bottom, and we're going to try it again. So I believe they give you a point for showing the 0 over 0, writing L'Hopital's, and then doing it correctly. Okay, 1 point for all of that. Now the second point is if you can do this part correctly. So this is going to be 4 times f prime of 3. And f prime of 3 was 8 over 3 times e to the 0. So we're going to get 32 over 3 times 1, which is 3, and that would get you a second point. All right, so 1 point again for recognizing L'Hopital's rule, 1 point for this right here. K gives us a piecewise function and wants to know if it's differentiable. So before we can talk about differentiable, let's see if it's continuous. Let's show the limit of k of x as x approaches 5 from the left. That would be the top part. So that's going to be f of 5 minus 5 squared. F of 5 was 25, so it's going to be 25 minus 25, which is 0. Okay. The limit as x approaches 5 from the right will be the bottom part. So that's going to be the natural log of 25 minus 20 minus 4, which is the natural log of 1, which also is 0. Okay, so we have a limit from the left equal to the limit from the right. So k of 5 is also equal, because of the equal here, k of 5 is also equal to 0, which equals the full limit. And so therefore k of x is continuous at x equals 5. So if that had been the question, that would be what you want to show. The limit from the left equals the limit from the right. Therefore, we have a full limit, and we have a function value, and they're equal, right? That would get you a point, I think, here. Okay. Now, they asked about being differentiable. So now we want to say, well, what's k prime of x? So you don't want to jump here too soon. You have to show the continuity first. But now if we do this, we can write this as a piecewise function. The derivative of the top part is f prime of x minus 2x, and that's for x less than or equal to 5. And the bottom part, the derivative is going to be 1 over what's inside of there, times the derivative of that, which is 2x minus 4. I'm just going to stack that on top. That's for x greater than 5. Okay, so this is what the derivative expression is. So the limit of that as x approaches 5 from the left would be f prime 5 minus 2 times 5. So f prime 5, according to the table, was negative 10. We end up with negative 20 for that limit from the left side. So the derivative coming in from the left has a slope of negative 20. The limit as x approaches 5 from the right would be 2 times 5 minus 4 over 25 minus 20 minus 4. We're going to get 6 over 1, or 6. Okay? Limits don't match up. We have a sharp turn at x equals 5. Therefore, k is not differentiable. All right, and some version of that would get you a point. Something that shows the derivatives here, and that maybe, I would say, let's do this. I think they'll give you a point for showing the derivatives, and then a point for matching it all up like this. So I think this one could be worth 3 points. Okay. Now, it's still, this might be one you want to skip, because when you look at it and you're running out of time, you might not have had much time to get to here, or you see it and you're like, I know that's a lot of work. I'm going to try to hit some other ones. So don't worry that this one happens to be worth 3 points. It just, I think that's probably what they would do. Now, I says, does there have to be a time in the interval where f prime, double prime equals -9? Anytime you hear that, does there have to be, must be, a guarantee, something like that, that's that mean value theorem, right? So what we want to do is we want to look at what was f prime 5 minus f prime 3. What was the rate of change in the derivative from 5 to 3? And that would have been -10 minus 8 over 2, which is -9. Now, they'll give you a point for recognizing that's what you needed to kind of look at. Okay, and so by the mean value theorem, there must be an x value in 3 to 5 where f double prime of x equals -9 because f prime of x is continuous and differentiable. So that's the only requirement for the mean value theorem, is that continuous and differentiable, and we know that it is based on the very original statement in the directions. So the mean value theorem, and I think you may have to say continuous, but maybe they would let you off with just mean value theorem, but a second point there. Okay, so altogether we had 24 points. Okay, now again, I'm just guessing at this point. Don't hold me to it. I think if you want to have a 3, you need to have more, I would say more than 8. So 9 to 24, somewhere in there, okay? You got to have more than 8 if you want a 3. If you want a 4, I'm going to say you need to have more than 11. That's going to be, I'm just guessing, all right? So 12 to 24 range if you want a 4. And if you want a 5, I'm going to guess that you had to have more than, I'm again just throwing a number out there, more than 15. Okay? Actually, I'm sorry, 14. Now, I don't know. I'm not, I would never hold back on you. I have no idea how they're scoring this year. But if I had to take a guess based on what I just gave you, this is where I would put you 3, 4, or 5. All right? So hopefully you did well. And if you didn't, don't panic. It was a nice experience. Come Tuesday, you're going to do great.